Now let's move on to the mass generation. Mass generation, here we mention in our beam we construct our beam and add the steel plates. Now next step is mass generation. Mass generation, their mass generation is a structure mass that consists of only brick elements. Our one also it is brick element. Dimension. Their dimension brick element size of our mesh is 20 millimeter. Okay. Now let's move on to that part. Mesh. If we finite element mesh and generate and their size, our size is 0.02. We are 0.05. In the we try to do it 0.002. And if we model micro element, we mesh there we have to mass within the micro element model find the mass. If we mesh micro element and add there one is brick and okay. After that, okay, we have to select our beam. Then uh, here we have to go again. Now generate and we have to click generate. Okay. Here they didn't give the chance to global element size 20 millimeters because we don't have license there, especially not at ATENA demo version limitations. Now we'll add reinforcement. First bar. There reinforcement that topology and there is reinforcement bar. There add reinforcement. Here come another window open. Then polyline. Select there. Come. We have to add joint. First use joint. Add there. We have to give coordinate of the starting point. Starting point they give. What is the we check? What's the parameter of that? There we give starting point as a first that corner point. Then it is 0. The cover y the side, we have to give the side cover as 0.05 meter and bottom cover also 0.05. Right. And the last point is another that support side. Right. Then our beam length is half of the beam length is 1100. Then we have to minus cover 50 millimeter. Then it is 1.05. Same coordinate covers. Then next we have to go segments, and add segments. Their origin is 2 to 1. Between there to there, we create a line reinforcement. Then we can go to the reinforcement property, and there reinforcement to there we have this is area. Our bottom reinforcement area is necessary 16 millimeter. 16 millimeter means 1 6. Yes, 16 millimeter. Number of bar we can copy also. Number of bar we can put as a 1. Okay, it's only we have to add. Then we have to add button. Showing 2 to 1. Okay, this secondary bar sum click on first bar is added, and secondary bar you have to select that reinforcement, and reinforcement select copy and shift Y plane. We move the reinforcement along the Y axis and shift value. Shift value is come as the shift value is come our beam thickness is 0.15 meter, then minus 2 hours, it's mean 0.05 2 times, mean 0.1, which means we have shift 0.05. We have of the select copy shift 0.05, right? Okay. Now the secondary bar is done. Now we have to add torque reinforcement also. It's we have to define as new because their thickness is different. Then we go again, I go and join coordinate is TBI. X, Y, Z, and X is same, Y also same, is a distance. Height is 300. We have to minus cover. To 5. The coordinate is uh, 1 consonant 0 5, and segment is 2 to 1. Their property or this subcurrent Gaussian dia is 10 millimeter. Then and then we have to follow same procedure and select that bar and copy shift along the y-axis. We add top and bottom reinforcement. Now we have to add shear reinforcement instead of in uh, there now we add bottom bars and top bar. Now we have to add shear reinforcement. It's mean instead of we uh, add add click the add button, and there you have to define joints. First you have to define this joint. It's mean that you we design the half of the beam. Then that we c- cut we cut at the middle. That point to we give some cover from that surface also. If you want, you can reduce it. It's in X. The I got as 0.050 millimeters and all the side. Why? Why mean that uh, from side beam sides to reinforcement we provide 50 millimeter cover and uh, bottom reinforcement we provide the 50 reinforcement cover like that. We have to define these all 4 points. Then at all the 4 points and we have to make a line in order to we have to make a lines. It's we go to segments and add. Then we have to provide there join. You define 1, 2, 3, 4. It's automatically happen when you add the coordinate. It's automatically happen. Then you go to segments. You have to give the direction of the line. 1 to 2 let's go. 2 to 4 my one is go to this line. Then 4 to 3. Then 3 to 1. This is the complete uh, syrup. One syrup. Then I have copy this reinforcement and there they cube in our research paper. Uh, 200 spacing they provide. Yes, linear spacing they provide. Then I'm going to provide. hmm, Uh, then we have to select that reinforcement and copy. We have to now move along the x-axis between x-axis. They don't have option. Then they have option. Then it's already in from origin to 50 millimeter away from the origin. Then we have to add 200. Then to have 2 and and one copy. Yes, should copy. Then another 200. 400 it's me. Copy. Then another 200. 650. Copy. Then another 200. 850. Copy. Then we try to see what happened. 0, 7, 0. Is go to the outside of the reinforcement. Then I have to erase it. I go to reinforcement. Then I select that remote 10. It is 10. Then I had to remove that. Then I select number 9 and copy. They also mention additional force strap on the either side of the apparatus, but they didn't mention the stirrup. Uh, we know now the, that the uh, support we have to put more shear enforcement. Uh, but they didn't mention the speaking of that stuff. Then I have to go next step. If we find that one, we can provide that thing also. Now let's move on to the next part. Steps and action. Supports and action. There, loadings. Root cause now loadings. Loading, loading case. Loading cases. Now click the add and loading case support. Mhm. Click the add. And second one is deformation. Specific deformation. Cancel. And we have to select support position. And go to the load surface and add. Here we have to define the correct condition solution of the support in the X, and there our x-axis along the x-axis is we can't move. There it's fixed. In that case we have to go to the next surface and add surface. There we have to support condition along the x-axis we can't move. It is so we have to put axis as a fix. And okay, we have to select which is our select this surface to apply the boundary condition. This is our middle of the beam. Then okay, we add their support condition because the beam middle we can't move. And now we have to select at the support our support there. We have to this support we have to move. This support we have to add boundary condition. Then there x is free along the x we can move. Then y is fixed, z also fixed. And the support we can't move. And there they said in this dialog the attributes of the required boundary condition are to specify the support in the y and z direction and click OK. After OK, the boundary condition. Now let's go to the next step and suppose to micro element and edit. We have the second one which is loaded in one edit. Edit. Here they we have there is all methodology and recommended methodology. We say to select second micro element and go to the click the edit button and go to the lines and select the 5-4 line and yes 5-4 line of line. And here we can do this step as the there is old method then recommended method. I go through the recommended method. There first I say that we have to first select second micro element and edit, and you have to go to the line and you have to find the which is in neighboring surface line. This I already selected and delete. You have to find that middle line. The then you have to delete and okay. Now loading history and solution parameters. Then you have to run and solution parameters and then add and you have to do some document this side is another then I select and edit editing to chance to edit then another at canvas option first 30 the same where we have to go take after this there I had same in the tutorial data 10 10 10 also so run then one versus step and this step and add load cases okay, and the load case is 1 to 2 number of velocity steps is 40. Is 40. If I mm, okay, go down, add according to the dialog 8 here, middle of the beam, middle of the beam, then add then value value at the node and displacement. They will select component 3 macro elements and component micro element 1. Mhm. Which is middle of the beam, with middle of the width means 0.075. Mm. Add from there maybe this. Okay. We have to add the top point of the load active. Now add which is on the steel plate. Then title is load value at the node, value the action component 3 is axis now, which is active on the steel plate. Steel plate middle point is 0.333. Y is middle as previous, which means 0.75, and this one is height of the beam plus 3. screen on this one. Okay. We add all the things. First, we have to edit that name. Okay. Deflection. This for deflection. Edit. Deflection. Now we can run the program. First, we have to save. I save another file also, otherwise, if it is damaged, I can use it. Now we can run. If you come to the run, then from the run window. Okay. Now I'm stuck in this video.